Imagine a spot in space where gravity is incredibly strong, trapping even light itself. These cosmic traps are called black holes. They form when a massive star reaches the end of its life and collapses. But first, let us tell you everything about black holes. These gluttonous beasts are some of the most fascinating objects in space. But these gluttonous beasts have left physics in a crisis mode ever since 1974, when Stephen Hawking argued that black holes destroy information. These mysterious black holes are invisible because no light can escape them. But guess what? Special space telescopes equipped with unique tools can actually help us find them. They do this by observing how stars behave when they're very close to these invisible giants. Have you ever wondered how something invisible can have such a strong pull? Or why only certain stars act differently near black holes? Exploring black holes raises fascinating questions about the secrets of the universe. Let's start with history and theory. In 1795, Pierre-Simon Laplace envisioned an extraordinary idea, an object so dense that even light couldn't flee its grasp. Using Newton's theory of gravity, Laplace calculated that if something were squeezed into a small enough space, its escape velocity would surpass the speed of light. This superdense core forms the heart of a black hole, known as the singularity. Imagine the event horizon, the hole's entrance, as its mouth. Once anything crosses this boundary, it vanishes entirely. Inside this boundary, known as the event horizon, all events in space-time freeze, preventing anything, even light, from breaking free. The size of this boundary, called the event horizon's radius, is termed the Schwarzschild radius. This term honors the pioneering work of astronomer Karl Schwarzschild, whose insights were fundamental to our understanding of these enigmatic cosmic entities called black holes. Ever wondered what secrets might be locked beyond this invisible boundary? Or how the freezing of time within a black hole might work? The mysteries of black holes continue to captivate and intrigue us. But before that, make sure to subscribe to this channel. Join us on this thrilling cosmic expedition. But wait, you think there's only one black hole? No. Approximately 1 in 1,000 stars has the potential to transform into a black hole, as per the Space Telescope Science Institute. Imagine this. With over 100 billion stars twinkling in our Milky Way, there could be around 100 million lurking black holes hiding within. Detecting these cosmic enigmas is no easy feat. NASA estimates that within our galaxy, the Milky Way, there might exist anywhere from 10 million to a billion stellar black holes. Now picture this cosmic marvel. The closest black hole to Earth is nicknamed the Unicorn, residing around 1,500 light-years away. What makes it special? Well, apart from being in the constellation Monoceros, which means the unicorn, its mass is incredibly low, just about 3 times that of our Sun. This uniqueness makes it stand almost alone in its kind in the cosmic expanse. Isn't it fascinating how something so mysterious and rare can exist relatively close to us in the vastness of space? So, how big are black holes? Black holes can be big or small. Scientists think the smallest black holes are as small as just 1 atom. These black holes are very tiny but have the mass of a large mountain. Mass is the amount of matter or stuff in an object. Another kind of black hole is called stellar. Its mass can be up to 20 times more than the mass of the Sun. There may be many stellar mass black holes in Earth's galaxy. Earth's galaxy is called the Milky Way. The largest black holes are called supermassive. These black holes have masses that are more than 1 million suns together. Scientists have found proof that every large galaxy contains a supermassive black hole at its center. The supermassive black hole at the center of the Milky Way galaxy is called Sagittarius A. It has a mass equal to about 4 million suns and would fit inside a very large ball that could hold a few million Earths. But what do black holes look like? Black holes have three layers. Black holes have three layers: the outer and inner event horizon and the singularity. Imagine the event horizon as the boundary encircling the mouth of a black hole. Once anything crosses this boundary, even light, it's trapped inside. Gravity remains constant across this zone. Deeper within lies the singularity, a singular point in space-time where all the mass of the black hole is concentrated. Scientists can't see black holes the way they can see stars and other objects in space. Astronomers use indirect methods like detecting the radiation emitted as dust and gas spiral into these enigmatic voids. However, supermassive black holes at the center of galaxies might cloak themselves with dense gas and dust, hiding their telltale emissions. Sometimes, as matter is drawn toward a black hole, it ricochets off the event horizon and is hurled outward, rather than being tugged into the maw. Bright jets of material traveling at near relativistic speeds are created. Although the black hole remains unseen, these powerful jets can be viewed from great distances. Remember that incredible image of the black hole in M87 captured by the Event Horizon Telescope, or EHT, in 2019? It took 2 more years of analysis after taking the images due to the massive amount of data collected by the collaboration of telescopes worldwide. This collaboration generates an immense volume of data, too large to transfer via the internet. With time, researchers expect to image other black holes and build up a repository of what the objects look like. The next target is likely Sagittarius A, which is the black hole in the center of our own Milky Way galaxy. Sagittarius A is intriguing because it's quieter than expected, which may be due to magnetic fields smothering its activity, a 2019 study reported. Another study that year showed that a cool gas halo surrounds Sagittarius A, which gives unprecedented insight into what the environment around a black hole looks like. Imagine what more we'll uncover about these cosmic mysteries with continued exploration. Have you ever heard that black holes are a one-way street? But how? Nothing seems more hopeless than trying to get out of a black hole. In fact, this impossibility is what defines black holes. When an immense amount of matter gets confined within an incredibly tiny space, space-time collapses upon itself in a violent cycle of squeezing and stretching, intensifying this squeezing and stretching even more. These tidal forces reach an infinite level in a finite span of time, abruptly ending an entire region of space-time at the black hole singularity, a point where time halts and space loses its meaning. Within this collapsing zone lies a critical boundary that separates the region where escape is conceivable from the point of no return. This boundary, known as the event horizon, represents the outermost boundary from which light barely evades, falling into the singularity. Anything trapped beyond this horizon, unless it could travel faster than light, which defies the laws of physics, is irrevocably trapped within the clutches of the black hole. Initially, this one-way boundary seems consistent and solid, aligning with the predictions of Einstein's general theory of relativity. The trouble brews when this theory encounters the unpredictable realm of quantum mechanics. If black holes are black, how do scientists know they're there? Black holes present an extraordinary challenge to observation because their immense gravity traps all light within, rendering them invisible. Yet, scientists can detect the impact of their strong gravitational pull on nearby stars. By studying the behavior of these stars, scientists can deduce if they are orbiting around a black hole. When a star and a black hole are in close proximity, they generate high-energy light that isn't visible to the human eye. To observe this high-energy light, scientists use satellites and space telescopes specially designed for such detections. The concept of black holes stemmed from precise mathematical solutions to Einstein's equations formulated in his theory of general relativity. Carl Schwarzschild discovered the black hole solution in 1915. These regions, known as black holes, were found to distort space significantly, creating a rupture in the fabric of space-time. Initially, it was unclear whether these were actual entities in the universe. However, as scientists detected other remnants of stellar deaths, such as neutron stars observed as pulsars, the existence of black holes gradually became more evident. The first identified black hole was Cygnus X1. Astronomers have categorized black holes into three primary types based on their mass and size: stellar black holes, supermassive black holes, and intermediate black holes. These distinct classifications highlight the diverse nature of these cosmic entities and their roles in the vast cosmic landscape. Stellar black holes, small but deadly. When stars reach the end of their fuel, their fate after collapse depends on their size. Smaller stars, up to about 3 times the mass of our Sun, form dense cores known as neutron stars or white dwarfs. However, when larger stars collapse, they undergo continuous compression, resulting in the creation of stellar black holes. These black holes, born from the collapse of individual stars, may be relatively small but possess an incredible density. Imagine packing more than 3 times the mass of the Sun within the confines of a city's diameter. This immense concentration of mass generates an extraordinary gravitational force that exerts a profound pull on objects surrounding the black hole. As stellar black holes consume surrounding dust and gas from their galaxies, they continuously grow in size, feeding off the matter around them. This relentless accretion of material contributes to their ongoing expansion. Supermassive black holes, the birth of giants. Indeed, while small black holes exist throughout the universe, their counterparts, the supermassive black holes, take the center stage. These colossal entities are millions or even billions of times more massive than the Sun, yet they maintain a relatively similar diameter. Remarkably, supermassive black holes are believed to reside at the cores of nearly all galaxies, including our own Milky Way. The precise origins of these massive black holes remain a mystery to scientists. However, once these behemoths form, they accumulate mass from the abundant dust and gas surrounding them, particularly concentrated at the centers of galaxies. Supermassive black holes, the birth of giants. Indeed, while small black holes exist throughout the universe, their counterparts, the supermassive black holes, take the center stage. These colossal entities are millions or even billions of times more massive than the Sun, yet they maintain a relatively similar diameter. Remarkably, supermassive black holes are believed to reside at the cores of nearly all galaxies, including our own Milky Way. The precise origins of these massive black holes remain a mystery to scientists. However, once these behemoths form, they accumulate mass from the abundant dust and gas surrounding them, particularly concentrated at the centers of galaxies. This material serves as a buffet for these giants, enabling them to continuously grow in size and scale, expanding into even more colossal entities. The process of accreting matter from their surroundings contributes significantly to their staggering increase in mass, making them the gravitational powerhouses observed at the hearts of galaxies across the universe. Let's have a quick Do You Know session. Fact number 1. If you fell into a black hole, theory has long suggested that gravity would stretch you out like spaghetti, though your death would come before you reached the singularity. But a 2012 study published in the journal Nature suggested that quantum effects would cause the event horizon to act much like a wall of fire, which would instantly burn you to death. Fact number 2. Black holes don't suck. Suction is caused by pulling something into a vacuum, which the massive black hole definitely is not. Instead, objects fall into them just as they fall toward anything that exerts gravity, like the Earth. Fact number 3. The first object considered to be a black hole is Cygnus X1. Cygnus X1 was the subject of a 1974 friendly wager between Stephen Hawking and fellow physicist Kip Thorne, with Hawking betting that the source was not a black hole. In 1990, Hawking conceded defeat. Fact number 4. Miniature black holes may have formed immediately after the Big Bang. Rapidly expanding space may have squeezed some regions into tiny, dense black holes less massive than the Sun. Fact number 5. Astronomers estimate that the Milky Way has anywhere from 10 million to 1 billion stellar black holes, with masses roughly 3 times that of the Sun. Fact number 6. Black holes remain terrific fodder for science fiction books and movies. Check out the movie Interstellar, which relied heavily on Thorne to incorporate science. Thorne's work with the movie's special effects team led to scientists' improved understanding of how distant stars might appear when seen near a fast-spinning black hole. Thanks for exploring the mind-bending mysteries of black holes with us. If you enjoyed diving into the secrets of the cosmos, don't miss out on more captivating content about the wonders of the universe. Subscribe now to stay tuned for more mind-expanding adventures.